Hello and welcome to another processing demonstration, and today I am going to look at accessing data from the internet and specifically using the JSON format of data, JSON, that is. I call it JSON because it looks like it should be somebody's name. And this is a very common data provision format. The other common one would be XML, flavors of XML. And there's a few more actually, but data is fairly standardized when you retrieve it from websites. Last unit we looked at tabular data, but the data we're going to look at today is a lot more structured than that, and it actually has sort of a metadata component baked in, so that when you're looking at the data, it's more or less self-documenting, and I'll tell you what I mean about that. So what are we going to do today? I have a program here that just retrieves the local weather from a service that provides this, and I'm going to run that for you. Right, and that's all it does. It just puts up a panel with, oddly, they've got the Irish for Limerick. I've no idea why, because it's the only city in Ireland they do that for, but there you go. It's not 3 degrees out, and it's not 93% humidity. This sketch that I'm running is actually working off a saved data set, a test data set. And there are advantages to doing that when you're working on a program and debugging, and I'll explain that as we go. So this is not very exciting. In the next unit, I will look at how we can graph this data, actually how we can map it, involve some graphics, involve some interactivity, and so on. But we're not doing that this unit. We're just showing the data format and a few tips as to how you should go about obtaining such information off the internet. So knowing what we already know there, I can start writing a typical sort of outline of a sketch, which at this point should be pretty self-evident. But I'm going to go through it anyway, just because practice makes perfect. Though apparently I still, make typo errors for sure. So I'm just going to use a small little panel like we just saw. And the background was white, and the fill color was black. And I may as well be complete and put in no stroke there. And I'm using a particular font. You can, of course, specify any font on your system. But when you're distributing your sketches, you need to be sure that everyone else has that as well. So I made it really big here, 28 point. I will set that as the default font. So this you may wonder why I have this variable for the font defined locally in setup. Sorry, just correct this error here. And whoops, another error. Okay, you may wonder why it's defined locally in setup, and that's because once you set this as the text font, that is a global setting. So variable scoping is a little confusing because of the hidden stuff behind the scenes. You kind of need to know when you're accessing a function or a built-in class if it's affecting only the local variable scope or the global variable scope. And I just mentioned this in passing. So a lot of the these graphics functions that we've been using change things globally, not just within the setup. It's good to be very explicit about that in your head and keep in mind what's going on there. So what I'm going to do is I'm going to just have some function that I'll call weather. And then we already know what the program should look like. There's no interactivity, so I don't need a draw function, and I don't need to loop, so I may as well just, take care of that right now. There, save. Whoops. Whoops. Double whoops. Right, now save. So this is the bare bones outline of the program, and since all of this is like really simple at this point, I like just putting this down here to get myself going. Also have some comments at the top. Weather API demonstration. That's basically what this is. I'll explain what an API is in just one moment. So yeah, so this is an outline that could be practically any program at the moment, but at least it gets some typing out of the way. So so this is basically a framework, and of course you can just copy and paste this sort of thing off a sketch that you've already done. So how do we get data? How do we get this weather data? It turns out that it's not as easy as you might hope, because a lot of companies have commodified this data. Stuff that was free even 12 months ago or 2 years ago is no longer free, and that's kind of annoying. So there's this site called Open Weather, and you can see here on the home page. So it's openweathermap.org is where I've gone to in my browser here. And you can see that it's, apparently it doesn't know I live in Limerick, but it does know that I'm in Ireland. So it's probably got some geographical information at some point. So there's lots of cool weather maps and all the rest you can do with this if you're like a star coder, and certainly we won't be at the end of this short session, but we'll get there in small bits and pieces. But what I want to point out is you have to sign into this website. So I'm already signed in. Okay, so you'll need to register on most of these sites in order to get access to data. And even if you're not paying, so let's have a look at the pricing model over here. So free startup developer professional enterprise, $2,000 a month. Okay, you better really need weather data if you're going to pay that much for it. But the free account gets you an API key, and you can make no more than 60 calls per minute. This is really important. If you get a key to this API and you abuse it by misusing the terms of the agreement, then you will be banned, and good luck getting another one. So don't share your keys. So I should say, so when you sign up, then you get a key, and a key is a unique string. It's unique to you, and it's what you use to access to access the API. So let's just say we'll make a string called API key, and it's usually a long it's usually a long string of alphanumeric characters like that. That, of course, is not my API key. Don't share your API key with anybody else, because that's a great way to get banned as well. And then you'll never know the weather ever again in your life. It would be very sad. So let's see. So yes, an API is an application programming interface. Let me write that out. And it is simply the protocols by which you engage with this server that's going to deliver the data that you want. APIs can be simple, they can be very complicated, they can deliver data in various formats. This one happens to use the JSON format. And let me show you what you get. So if you request the weather in Limerick, and I'll show you how to do that, of course, in one moment. But if you do, let me show you. So this is my folder where my sketch lives. It's called weather. And in that I have a data folder. It's got my typeface file in there, so that that particular typeface and font is available. And then it's got data.json, which is the actual data that one might retrieve. So when you make an API call to this weather site and specify Limerick, it gives you back this. This is the data file. And so what I've done is I've saved this data file locally so that I can test my code and run it over and over again without spamming their server. Okay? Really important. You get 60 calls in a minute. That sounds like a lot, but it's only 1 per second. And in the next unit, I'll actually demonstrate how limiting that is. It's extraordinarily limiting for a lot of real-time work you might want to do. Right. So that out of the way, let's look at this data. The first thing you'll notice is that it's perfectly readable. There's no weird characters here. And everything is tagged. So every data value, so this value minus 8.63 is tagged with a label, LON, for longitude, and latitude 52.66, visibility, weather, name, COD, whatever that might be, main, don't know what that is, clouds, various information here. Now you'd need to read the documentation to know what all of it is. Some of it's kind of obvious. Down at the bottom we have the wind, speed 9.3. We don't know what the units are though. There's a couple more things that you might notice about this data. First of all, it kind of looks like code. It looks like we could almost just copy and paste this into our code and start using it. And indeed, that's kind of the benefit of the JSON format, is it does have data and metadata mixed up together. And it is very usable in different programming languages, including in the processing environment. So you can see it starts with an open brace, the curly brackets, and it ends with one. And whenever you see stuff within the curly braces, which you do a lot here, that is a what's called a JSON object. But you'll also see here that there's square brackets, which we're used to seeing in arrays in processing. And sure enough, that is a JSON array. Now in this case, the array has within it one object, but I suppose one might expect that there could be multiple items in an array as well. So that's kind of most of what we need to know. There are two basic structures here. There's a JSON object and there's a JSON array. They can be nested to various levels of depth. So this is a hierarchy. So within the overall structure, we have coordinates. Within coordinates, we have longitude and latitude. And you know, we could that could drill down as many layers as one needed to provide, you know, a structured set of data. Right. So we're going to read this, and we're certainly not going to read it by sort of parsing a string and looking at where quotes and colons are and all that sort of stuff. Nope. We're going to use a built-in library to read it. And because JSON and XML and these other standardized formats are so popular, every contemporary programming language has libraries for them. So let's just do that then. Right, so everything we do is now going to be in this weather function. Actually, I'll even center it on the screen a little bit. Not that it probably matters, but this can be nice and small. And I can start thinking about what data I want. So first of all, I'm going to look up the latitude and the longitude of Limerick. 52.6613. Now I'm using variable names that kind of map onto the data. You don't have to, of course, but I don't know. It just seems a natural thing to do. And you might know that we're at -8 degrees relative to Greenwich median, 6302, I believe, -8.6302. Right, so that's some information that we might, well, want to use. Now, how do we actually access that the data that we want? Current weather API. Well, if I click on that, call current weather data for one location. So you can do it by city name, by city ID, by geographic coordinates. So it looks like that's what we're doing, by geographic coordinates. So here is the API call with the parameters latitude and longitude. So a good place to start would just be to copy this out of here. And let's make a string. We'll call it the URL. And we'll start it off as being this. I'm going to need to make this bigger, aren't I? This is like a lot of stuff. So the first thing is this is a web address. So you need to put in the correct protocol, HTTP, not L. It could be HTTPS if it was secure, but in this case it isn't actually. So so that is the URL, sub data, sub 2.5, sub weather. So that's the URL, and then the rest are parameters on the end of the URL. And the first one is the latitude. So what we want to do is put in our latitude here. So that would mean we need to concatenate the string, something like that. And then there's another bit of string. And then there is our actual longitude value. These braces they have here are just placeholders. You don't include the braces in the data, as I found out the hard way by trying first. So longitude goes here, and then we have another parameter, API ID equals your API key, which I actually called that API key, didn't I? Like that. Okay, and all the errors have gone away. That's correctly formatted. Now I'm gonna just break this over a couple lines there, just so we can see it a bit easier. Okay, so that is our string that acts as an API call to this server. We've broken down what they gave us, and we've substituted in where we have variables. So latitude, longitude, and the API key, which is this fake one up here, okay? So that together should, oops, there's some nonsense at the end there. There we go, that's better. That will make up our function call. So different sites will have different formats for this, but you just grab it out of the documentation and parse it out as I just did and figure out what you want where. Okay, so in actual fact though, I'm going to test with the local data. So if I was going to retrieve this, I would actually do it like so. And you only know this by looking it up in the processing documentation, but there is a function called load JSON object. Again, I know it's an object because I know what the data looks like. And you give it the URL like that. And the data is of type JSON object, right? So the error has gone away now. If you can see, there is a bit of an orange underline here, but that's just a warning to us that we haven't used this value yet in our program. It's not an error per se. So that's how we would retrieve the data from the server. And if we're using local data, it would be very, very similar, except our URL would be different. Let me just put it in below. Instead of a remote address, we can just specify a local address. And as I've explained before, processing will look in the current folder and all subfolders for this resource that it needs. So there's no need here to specify an absolute path to this data file. And in fact, it's very much less flexible when you do that, because if you just happen to reorganize your folder here where you're putting things, then you could break an address here if you were being explicit. It's much better to be general like this and have processing figure out where the data is. So let me comment this out so that there aren't two similar lines there. So I'm going to retrieve local data, the file I just showed you that I've already grabbed off the internet. And again, I want to emphasize this is best practice to do this. It's the way to do it. Grab sample data that conforms to what you expect, and then use that sample data locally to test so that you're not spamming someone else's server with requests that could be malformed until you debug your program, or by accident you could send 1,000 requests in 1 second, which wouldn't be a good thing. So this gives us a JSON object that contains the entire contents of this file. So now it's our task to drill down into that data to retrieve the particular nodes that we want. You can look at it as a tree with different branches, and you need to find the particular leaves that have the whatever we're looking for. So data holds all of this, and we want to get specific data elements out of that. So it turns out that the information we were displaying is all in this key main. That's got the temperature, the minimum, the humidity, the pressure, the maximum. I'm not sure if we're using all of those, but yeah, that's what we want to extract. So this, as you can see, is another JSON object because it's got the curly swirly braces on either side. So what we actually want to do here is JSON object main, may as well call it main. And this is within our overall data structure. So within the data that we already have from the previous line, we're going to get the specific object we want, which is also called main. Why is that giving me an error? Does not exist. Oh, that's because I spelled it wrong. There we go. Yeah, it's a kind of tricky, like some of these letters are uppercase and some are not. So you only use load JSON object once on your file. That loads the whole thing into your program. And then you use get JSON object or get JSON array to parse down into the data. So at this point, I really kind of want to run my program and see what it looks like. So I'm going to just print the results of that and just run it right now and make sure it works. Obviously, it's not displaying anything yet, but you can see down here in the console, it actually is showing us exactly that part of the data file. So it seems like things are behaving so far. Okay, so now we want to go further. So from main, we now want to extract particular data items. So temperature, for example, does not have parentheses around it. It does not have the braces, I mean. It does not have square brackets. It's just a data item. So now we need to use a suite of functions that will return specific data items. And the temperature there is a float. Interestingly, we might want to deal with that a bit. So get float, and it's called temp. So that will return temperature. So let's just set up, again, a variable with the same name. So again, within main, which is what we see below here, we want to get the float with the label temp. So all this has to conform, of course, to our data, but it looks fine to me. Now notice the temperature, 276 degrees, 0.15 even. That's pretty warm. That's because we're actually working here in degrees Kelvin. I have no idea why they would be returning data in degrees Kelvin for weather. Unless they want to look at the weather on like a moon of Titan or something. Or sorry, Titan is a moon on Titan or some other solar body. So what we need to do immediately is subtract off, those of you who are scientists know this, 273.16. If you subtract that off, then you will get degrees Celsius. And if you want degrees Fahrenheit, good luck to you. You can convert if you really needed to. And then what I like to do is round that off then. And to do that, I will just use a function called round. So that will give us the temperature in round numbers. That should be a little nicer. We've got pressure. And pressure looks like it's an integer. Like that. And we've got humidity. And that looks like an integer. I'm not going to worry about the minimum and maximum temperatures, especially since it looks like they're not being updated properly because they're both the same as the temperature. But I do want something else. I do want the name, the location name. So for this, we might have to do this a little bit differently. It's not in this little bit of data that we're looking at now. String, let me just set it up though. So the location is, let's see, here. That's the location. So it's in our top level data, which we just called data. And it's a string. And I can't remember what it was called. Even though I just looked at it, it's called name. Okay. So the name of the weather station, I guess. Like that. So again, you just pluck out what you need. So the only array we have in this data set is the weather. It's got an icon descriptor. Don't even know what that means. A description, broken clouds. I mean, that would be nice to have. In fact, we did have that in our demo. Something called main, which just says clouds. I don't know what that's about. That's probably something about like rendering graphics, and it's got an ID for this as well. And that's all in an array, even though there's only one element in the array. So it's an array of length 1. But nonetheless, let's deal with that. So weather is an array within our data. So what we need to do is define a JSON array called weather. The whole thing is weather though, but oh well, we'll call it that. And it is, we retrieve that from data with get JSON array, specifying the correct string like that, and should be data. Now, it's an array. It's a particular length. There will be a size available to us, but ahead of time, we don't necessarily know how big that array is. I mean, I'm looking at the data and there's only one element, so I guess we could just retrieve the first object from it and assume that there's never going to be any more elements. That's probably okay for now, actually. So the element within that array is, as you can see from the braces here, the curly brackets, is another object. So each element of the array is a JSON object. And it was the description. So it's weather, the first element in weather. The type of the expression must be an array type, but it resolves to JSON array. Oh, right. I can't just say the 0th element. It needs to match a JSON object. So I need to get JSON object, as I did above. Get JSON object, and we want it to be the 0th one in there. So I think that is more correct. Yes, that's more correct. We still need to get the description out, so maybe it's best just to call this something random like that, because we still need to get the description out, which is a string. So I'll just copy this string is within W, and it's a string labeled description. Okay, let's just call it description then. Right. Okay, that's all I'm going to get out of this data. You can see there's a lot more that one can fool around with. So let's just print this up to the screen then, which is kind of a boring process. I think what I'll do is I'll copy and paste from one I cooked earlier, just to save us time, like that. So I'm gonna put text. It's gonna say location, and then the location. And where am I gonna put it? I'm gonna put it the width of the screen times a small fraction, which will get us an offset from the left-hand side of the screen. And then each one will be at a different height. And again, I'm doing them as percentages of the screen, which is different than how I did things in the last unit, just to illustrate that there definitely is more than one way to do this. Last time I actually had a variable for the leading, and I incremented a variable for the Y position based on that leading each time I printed to the screen. So this is just a different way of doing it. Okay, I wonder if I run this. Yes. Oh, I've still got the print line statement in there, which I don't need. So it says 3 degrees, 93%, and broken clouds, and so on. Now, if I replace the API key behind the scenes with my actual API key and run this. Oh, and of course I need to change the line here. So instead of reading locally, comment that out, and instead read from the internet. There it is. It's actually 7 degrees out. Oh, pretty chilly still. 91%, and still broken clouds. Yes, I think probably they could just keep that description in the Limerick weather forever. They wouldn't be far wrong. So that's just to illustrate that it works, basically. I don't need this print line statement anymore. That's basically for debugging. I can just comment that out. Okay, so I hope this was useful. It was basically just a description of how to use the different JSON functions and how you use them to kind of drill down to different branches in the data tree to get the actual elements, the leaves at the end that you require. And I also said a few things about workflow and how to access stuff from the internet. So the trick is to find data that you can get for free or within your budget. And the second trick then is to figure out what the heck to do with it. So this is, this would just be something that might pop up every morning. So I know what the weather is before I decide what to wear leaving the house. It's not very interesting. It's not dynamic in any way, shape, or form. So in the next unit, I want to do something about that. I want us to get a bit more into using graphics and more expressive modes of delivering the data, which after all is what data visualization is all about. But thanks for watching this unit, and I'll have another one for you very soon. This is Robin, over and out.